Hey, hello. Welcome to this EDB webinar. Today we have a very interesting topic, Postgres on Kubernetes. So let's get started. First of all, my name is Angel Camacho. I am the Director of Product Marketing for Databases here at EDB. I've been in the industry for quite some time, working on some iconic companies. But in my last role, what I'm doing is now I'm helping to promote everything databases within EDB. We do Kubernetes, we do private cloud, public cloud, database as a service. So today's topic, we're going to be talking about cloud native, and we're going to be talking about databases on Kubernetes. So let's go to the information. So first of all, what is cloud native? Cloud native is a very interesting topic, and it's on everybody's top of mind because most companies, what they want is they want agility. Most companies, they see that their competitors are going faster, deploying applications and providing digital experiences for their own customers in a faster way. So most companies, what they want is they want to build value and release new applications. But at the same time, they want to migrate from legacy databases because they are not as agile as modern databases. They want to embrace cloud technologies because that gives them agility. So in order to do all that, what they need is they need to simplify their infrastructure. There's need to be a lot of changes in how they operate and how they work. They, in order to have a focus on innovation, they need to embrace new features and provide their builders, their developers, their architects with all these new features and functions that modern platforms can give you. So embracing scalability, portability, deployment of speed are all big tenets on how customers are moving and adapting into a cloud native deployment. So let me give you an example on what means to be cloud native. I'm not saying that microservices is cloud native, but I'm using microservices as the example because with microservices, you can make big solutions easier to develop and allow businesses to move faster. This gives you control over the scalability and reliability. And depending on the data platform, you can reutilize the skills that you learn. Like, for example, you are migrating off a legacy database and you are going into a new database. You want to be sure that you have portability in your skills. Yes, but now what about the technology? You want to be sure that you can deploy on one place and keep developing across your entire platform, avoiding vendor lock-in. This accelerates deployment speed because you don't need to be migrating from one platform to another one or moving in a harder way. So what microservices allows you is imagine that you have a big application. Break it into little pieces. It's a big problem, break it into little pieces. So for example, you have your inventory, just to say something about e-commerce, or a banking application. Each function within your application can be deployed as a microservice. That means that it's a smaller um, service, a smaller piece of code that you control that provides services to the rest of the application. That's what it's called, microservices. We make it smaller. This is a new architecture. We make it simpler to use, and you can connect all them to make a bigger application. So how do we do that? We use something that is called containers. With containers, you package everything that you need to run one of these services in a simple to use package. It's a runtime, okay? So for example, you can put the login process of your application in a container. That means the code, the libraries, in our cases, the databases maybe, and you can connect everything to build a microservice, okay? So now you have a container. Instead of a large application, you have a dozen containers building your application. When you need to scale, probably, and when you need to grow, you probably can add a second container. That means two containers collaborating. And imagine that this is like a cluster. So we call this a pod of containers. So now you can have more containers. You can, if you are having a login storm, that means everybody logging in at the same time, probably you can have more containers supporting that function, and you can build scalability without scaling the other things that are not disturbed, right? So you can start seeing the advantages of containers. You build a little bit on something, you make it bigger, you build more of them, and you can service the entire architecture. Now, the problem is that when you started talking about one single application, now we're talking about a couple of dozen containers, and it's only one application. If you have multiple applications, so you've been scaling and growing, now we're talking about dozens, if not hundreds of containers. So how you are going to control each container, because each container is just like an individual computer, right? An individual service, an individual server. So we use an orchestration tool, a container management system that is called Kubernetes. Kubernetes is an open source technology. You may already heard of it probably. So this Kubernetes platform, what they do is they can control and connect with all your containers in a pod or multiple pods, that's a cluster, multiple clusters, and isolate them from the rest of the architecture, providing a virtualized environment. These are not virtual computers. Don't confuse that with it. These are containers. They are self-autonomous, portable, packaged software that you can move around, whoever supports containers. And you can run it on Kubernetes. So you don't need to install another operating system for each container. It also virtualizes the hardware, so you can use it on the cloud or on premises as far as you provide the Kubernetes platform. So let me put these together to see if it's we can make it clear. So cloud native technologies include containers and Kubernetes. We explain what a container is, and you use Kubernetes to control all your containers, okay? This enables the deployment of new modern architectures, like, for example, microservices. Microservices, as I mentioned, is breaking out a monolithic application into smaller pieces and segments. So now, because you are cloud native, you can deploy modern applications that make it easier to build new applications. Like, for example, now you already have a nice login process. You don't need to build a new one when you are building a new application. You just provide that service to your new application. That accelerates your development cycles. Now, because this is also a virtualization layer, that means that your containers do not depend on the system that you are running it on. You can move your containers to anywhere that you are providing a Kubernetes platform. That means that you can move them to another data center, to another rack of computers where you are running Kubernetes, or maybe you are running it in the cloud in one of the hyperscalers Kubernetes platforms offered by them. So you can seamlessly move the container to the cloud, move it to another rack, move it to another data center, maybe move it to a different town, country, or even a different continent. Now, this helps you realize what is in for the business, right? You are making your development agile. You are not only breaking a big problem into smaller problems, but you are building an architecture that allows you to move into microservices and modern architectures. Like, for example, another architecture that I'm thinking in right now is CDCI, continuous integration and continuous delivery. What means with this architecture is that you get your containers and you put it in your development flow. You connect your containers, your databases, your applications, and as soon as you are done, you can move them down to the next step and down to the next step, and then Q&A, and finally into production. So you are simplifying all the processes. You can build things faster and move it around to the cloud, on premises, anything in between. So there's a few things that I want you to remember that are very, very important. Being cloud native doesn't mean that you are really in the cloud. There's people whose policies indicate that they cannot run in the cloud for whatever reason, regulations, privacy, the investments that they've made in their own data centers, agreements, whatever. There are many reasons. But being cloud native means that you have the agility built in containers and Kubernetes for these modern architectures. So you can really deploy a cloud native architecture inside of your data center. Let's say in your data center at your office, you have a rack of servers, you have Linux and Kubernetes running. You can deploy Kubernetes in there, right? Now, the other important distinction is that containers is not Kubernetes. As I mentioned before, container is just a technology to package everything together. Most software vendors offer their containers already. Like, for example, EDB, we offer a container for our databases. So you can download this container and deploy it as many times as you want, wherever you need it. The important thing with Kubernetes is that it is the tool to manage the containers. Containers, honestly, can go out of hand quite rapidly because people get happy with them, they get comfortable, and they start deploying. And because they give results, they accelerate your deployment. Organizations start deploying everything through containers. So now it can be a nightmare managing them. So with Kubernetes, you have this control layer that helps you organize your containers. Now, let's focus on today's topic, the Postgres opportunity and what are the challenges for running on Kubernetes. First of all, why do you want to run Postgres in a container, right? Originally, the adoption of databases in containers was limited because in the original concept of a container, they were designed for ephemeral things. They were just little containers that will run an application stateless. They will die and the information didn't matter. But of course, when you are running a database, a data platform, the your data, your information is the most important asset. So you wanted to make it persistent. So it took a while until containers developed the concept of persistence, and you had storage connected to them, persistent storage, and all those kind of things. So at the beginning, a little bit of the adoption was slow. Then Kubernetes finally came into the place, finishing organizing all these problems because trying to deploy a database in Kubernetes was not simple. It was, you needed a couple of PhDs and a rocket scientist just to deploy it. But things were getting better and better. And now it's very simple. You just download a container from EDB and you connect it to your Kubernetes deployment service, and you are in business, right? So there's a lot of organizations adopting databases rapidly in a Kubernetes environment. Now, here is one gotcha, okay? Kubernetes are very good at managing containers, right? So what is happening is that the Kubernetes layer is communicating with that container or with that pod, managing replication or managing the life cycle of the pod or the container. But databases are unique. Databases have their own management systems internally. So you need to manage probably replication directly with the database. It's not just as like, hey, we replicate a container and we have two containers, now we have twice the power. No. What happens in databases is that if you have a container, you have another container, you need to connect them through a secure channel, and you have to make them collaborators, right? So for that, EDB provides a piece of extension for the Kubernetes layer that is called an operator. This operator is also open source in our case. And Cloud Native, the Cloud Native Foundation, has also a Kubernetes operator. But now let me tell you a secret. That Kubernetes operator by the Cloud Native Foundation is exactly the same as EDBs. Actually, we developed the container and we donated it as part of our open source collaboration with the community. So if you are using the Cloud Native Foundation operator called CNPG or Cloud Native PG, or you are using EDB's operator called EDB PG4K, sorry, EDB PG4K, you are using exactly the same operator. You put this as an extension of your Kubernetes layer, and now you have access to directly control PostgreSQL or EDB Postgres to utilize all the features available in the database within your containers deployment. So, because as I was saying, there's a lot of challenges running Postgres inside of a containerized environment. As I was saying, first is deployment complexity, right? I've been telling you containers reproduce a lot because people like it. So if you are building a microservices or CI/CD architecture, you're going to be needing a lot of containers. So it becomes complex to handle a lot of containers. So you need Kubernetes. Now, there can be operational overhead because now you need to do the Kubernetes management, but you also need to do the database management. So for day two operations, that's why we provide this operator, so you can automate and all these functions for the database. Now, as you can imagine, if there's downtime with your Kubernetes and Postgres, it would be very difficult to bring it back to a good state. So that's the reason why you want Kubernetes with the operator to facilitate all this life cycle and prevent downtime. And we're going to be talking about what EDB brings into the picture to help you optimize for these challenges. So enter EDB Postgres AI. What is EDB Postgres AI? Probably you already know, but this is an intelligent data platform. It's a unified transactional, analytical, and AI data platform for all your workloads. That means that from one single database, you can be running transactional, operational, analytics, and AI workloads without migrating data, just one single engine. Now, what do we bring specifically for deploying a Kubernetes layer on architecture in your organization? First of all, high degree of confidence. We can help you bring up to 99.999% of availability, uptime. That means just a few seconds in the year that you can have uptime. So we can guarantee this because we've been putting a lot of effort in building the enterprise grade features inside of EDB. And with the operator, we can guarantee failovers in between containers, which is important. We can guarantee that your data is going to be available, and we enhance performance. We can have up to 5 times throughput compared to just native replication in PostgreSQL. So if you are running all these and you run an analytic workload on top of your database, now you can run up to 30 times faster in analytical queries as compared to native Postgres replication and performance. Now, we're taking it also to the next level. We are providing AI tools that comes with EDB Postgres. Excuse me. So what do we mean by AI tools? Well, we built AI copilots. This is based on our 20 years of experience deploying Postgres. So, for example, one of my favorite copilots is the um, migration toolkit, AI migration toolkit. It's an artificial intelligence powered copilot to help you migrate off Oracle into EDB Postgres AI. So it goes, analyzes your code, analyzes your database, and helps you migrate. It automatically can help you migrate up to probably 80, up to 95% of all your code. Very little effort. So you just need to manually intervene with probably 5% of your code. In some cases, if you are not using specialized bells and whistles and hooks for Oracle, it will just move directly to ADB Postgres AI. So imagine what you can do. You can migrate off Oracle very simple using just one of those AI copilots. And we have many more for performance, tuning, all those kind of things. Now, because of all this um, compatibility with Oracle, we have the fastest on ramp into getting into a new platform. Why? Because you don't need to reskill your builders. They're already running with Oracle. They are already managing Oracle. It's very simple. It's compatibility at its best. So now you can have a modern platform, agile, open source platform as the foundation of your data layer and still reutilize your skills. Now, you don't want to be compatible with Oracle. You want 100% Postgres compatibility. That's also possible. I mean, it's EDB Postgres AI, and everything that we built as enterprise grade features like security, it's compatible with Postgres PostgreSQL. Now, here are some of the additional gains that you get. When you deploy EDB Postgres AI on top of Kubernetes using our operator, you get cloud native automation. That means that it can be very easy for you to connect and enhance your database, your development cycles, your administration, and operations around this new data layer. You can have a full life cycle control and in a declarative way. So that means that you can use the Kubernetes API directly to manage things inside of the data platform. Okay, so if you are using platform or infrastructure as code or any of these technologies, you can now use and deploy your data layer in the same fashion with the best results, because now you have consistent operations. No more guessing, no more people developing their own scripts, no more like, hey, I hope this works, right? You have an API, you can implement the process, and because we have this Kubernetes operator, we can do it. Now, here's another big thing. You can use here all these native functionality of the database with your Kubernetes and your modern architecture. But what if you are looking for extreme uh, um, availability? What if you want to break that barrier and go up to 5 nines? Well, you can use the enhanced version of our operator. Yes, I know, maybe confusing, but remember, cloud native and PG4K are exactly the same operator. We have built an additional operator that is called PGV4K. That is the one that provides HA and up to 5 nines of high availability. So more on that in a minute. With all these, you eliminate human error because it's already part of the operator, and you can consistently operate from in the entire life cycle of your containers. Okay. Now, because I mentioned PGD4K, Kubernetes have a very interesting feature that is a self-healing architecture. You can define triggers of operations, how much you are going to be offering in throughput, and if something fails, you can automatically define where you are going to fail over, how you are going to fail over, and what are the tasks that you need to take. Okay, so you can quickly restore functionality around your data layer, um, and in an automatic way. So it's peace of mind for IT ops and DevOps. Now, I've been saying that this is about deployment flexibility, right? I mentioned at the beginning that you can deploy wherever you have a Kubernetes data layer. Well, here is just a little example on where you can deploy. You can deploy in any cloud. All cloud providers, they have their own Kubernetes service, so you can migrate your containers from wherever you are and deploy them in the cloud. If you want to have on-prem and a little bit more control, we have partnered with Red Hat OpenShift, and we have certified our operators um, to give you that peace of mind that not only we have a great enterprise grade software, but it's secure, and we also have the agreements in place to help you support complex operations with Red Hat, for example. We work with IBM Power and Z Linux. So as you can see, there's a lot of flexibility to run on-prem or in any cloud. That's what it's called cloud native, because now you have the flexibility. You are not just constrained to one single piece of hardware. Even if it's in the same data center, you can use multiple hardwares. Remember, containers have the great functionality that these are that they are portable. You can move them wherever they are supported, right? Now, one of the additional enhancements that we've done for EDB Postgres AI is monitoring and observability. What do I mean by that? Well, we're talking about a lot of moving parts. We're talking about a lot of containers, deployments in the pods, potentially different infrastructure on-prem, in the cloud. That's the biggest superpower that we can offer you, the hybrid deployment that you can have. But now we are building, or we built inside our Kubernetes offer, observability. We built in a Prometheus exporter that you can connect with your dashboards, or you can connect with the Grafana, or you can use it in many ways, and you can really observe what is happening in the cloud. So mission critical applications need monitoring and observability. So with this, you can, with the Prometheus exported and connected to your dashboard, or Grafana, you can see what the database is doing. You can have observability into the performance and how it relates to the other services, right? So this is big for our users. Now, sure that it's in everybody's mind is security. And let's be real here. The open source community, we are committed to your success in terms of security, flexibility, all these nice ideas that we have and we've been building around. So this is what EDB brings to the table. Not only about the monitoring, observability, performance, and all that, but also enterprise grade security. We provide a software secure supply chain. That means that when you download software from us, even if it's just the open source version, fully open source vanilla PostgreSQL, we sign the binaries because we review the binaries, we harden and them, and we make sure that everything is compatible, secure, so you can deploy with confidence and build your applications with confidence. Now, on top of that, we provide enterprise grade security. For example, TDE, transparent data encryption, audit trail, privilege analysis, all these things that are required for building enterprise grade applications that your customers depend on. So you can build financial applications, you can build healthcare applications, you can build e-commerce applications, you can build gaming applications, any kind of applications, knowing that you are secure and safe. On top of that, EDB provides um, certificates that we comply with regulations. So, for example, we achieved the PCI DSS certification, so you can do credit card transactions and financial transactions directly on Postgres, EDB Postgres AI. We comply with SOC 2. We comply with a lot of regulations. We have a trust center that you can go and visit at enterprisedb.com. Search for the trust center, and you will see all the regulations that we comply and all the security features that we bring for enterprise grade security. Now, let's get us a little bit nerdy here. Let me show you this diagram. This diagram is just an example on how it or your architecture may look in the data center. And when I say data center, I'm very liberal about it. It can be any of the cloud vendors. It can be your own private cloud built through Red Hat OpenShift, for example, right? So what we have is, this is an example on how the people on the right-hand side of the slide, they are completely agnostic, know what is happening in the data center. For them, they're just connecting to your regular server that they always connect. You can have business intelligence systems. Remember, you can run analytic workloads here at the same time of your transactional workloads. You can have distributed applications. You can go and do CLI, that means command line interface, if you are inclined to do so. But you can do everything from just a single entry point into your data layer. Now, what is happening internally in your data center is you have multiple pods. That means you have multiple clusters, arrangements of containers providing all these services. And you can have them, let's say, if you are in a cloud, you can have one in one region and another one in one region. If you have data centers spread across the country or in two different continents, you can do so. Now, here is where things get interesting because, for example, for regulations, sometimes you cannot have or you cannot data across frontiers, boundaries, or things like that. So you can use PGD, our replication system, our high availability system, and define which data is going to be replicated and which data is going to stay local. Okay, that's another being important for security and compliance. So now you can replicate non-essential data or non-private information data around just to keep providing services closer to your customers, but you can keep your data private to just one single locality. That is one of the reasons why most of our customers, on-prem customers, decide not to go to the cloud, because they want to comply with regulations, keep all the data in just one single place, and replicate to a data center that may be across town or maybe within the state lines just to comply with the local regulations, and they are happy with that. Yes, we provide that. In some other cases, because you have customers around the world, you may need certain data, but not all the data, so you can replicate that closer to your customers. And again, because this is an agile development, you can have pods and clusters in different regions, different availability zones. And as a matter of fact, different clouds. You can have one cloud vendor in Europe and one cloud vendor in the US and one cloud vendor in Asia. And you can keep everything in sync and manage through Kubernetes. Because again, we comply with regulations, GDPR, PCI DSS, SOC 2, and many more. So those are the advantages that we offer in an architecture like that. And remember, everything is possible because we have the Kubernetes operator. So again, to recap, the container is your prepackaged environment, databases, applications, everything that you need to run. You can replicate them. You can deploy them anywhere you want. With the Kubernetes layer, you deploy them around and provide this platform so you can have containers in any cloud or any infrastructure. And with the Kubernetes operator, is just an add-on to Kubernetes. Now you can have specific control for databases, high and replication. Now, Speaking of high availability, we have enhanced EDB Postgres AI to provide up to 5 times the throughput that you will require, that you will achieve, pardon me, with the local replication. So these big gains for you. With again, with our high availability operator, we can offer you up to 5 nines of availability. That's a lot of uptime. And again, you can deploy across town or across the world for a real geo distributed data platform. And you can reduce TCO. We didn't talk about before, but I kind of probably you can assume that, because if you are leaving legacy data platforms, you are reducing your licensing cost, right? We can help you reduce up to 80% of TCO compared to legacy databases. So that's a very interesting proposition. You are reutilizing your skills. You can reutilize your code out to probably 95%, and you can reduce your cost compared to legacy databases just by using that compatibility platform that we offer. So again, this is all because of Kubernetes and our integration of ADB Postgres AI inside of containers, being able to deploy on Kubernetes and enhancing the experience through the Kubernetes operator that we offer. So with all that, now I can tell you that we offer continuous HA. We can offer the highest degree of security that you need for deploying your own applications. And now I'm really happy for this conversation. So why don't we just go into a Q&A? If you have questions, please feel free. I'm going to be here. There's some other people more knowledgeable than me here with me today. If you have questions, please feel free to start asking, and let me hear from you. Okay, so I see a couple of questions already popping up. Thank you very much. So Fernando is asking which would be the main learning resources for these technologies. So okay, so Fernando, there's a lot of resources to learn about Kubernetes and Postgres. Let me just highlight one that probably we don't mention often. This is the EDB training site. So if you go to enterprisedb.com/training, we have a ton of free training support for you. So that's on-demand training. If you want to go deeper into that, of course, we have trainer-led instruction, so you can have that. There's also a lot of free stuff out there, but let me tell you that our resources are free, and it comes from the creators and of a lot of the technologies that you will see here. So we are the main contributors to Postgres as the open source project. So you have a lot of resources there directly from the people building this. So use that resource. There's another question from Thomas. Thank you very much. Which Kubernetes platform can I use? Okay, I guess that this is about what are the supported versions, maybe, or maybe the cloud. So let me answer both on the same in the same question. So Kubernetes, we support Kubernetes 1.28, 1.29, 30, and 1.31 in our latest release of the operator. So you probably just need to go to the cloud and ask them which is the version of Kubernetes that they are supporting. For example, I know that Azure supports version 129. Google, GKE, they support 130. And I believe EKS, Amazon's Kubernetes distribution, is also 1.30. So those are the platforms that we support. But in reality, any provider that can give you a Kubernetes platform that is 1.31, 1.30, 1.29, 1.28, there's many more we support. So for a full list and the latest releases, please go to enterprise.com/docs and search for the Kubernetes platform, and you will see what is the latest that we support. Okay. Thank you. There's another question here from Robert. How can I add the top security features like TDE into my Postgres deployment? Well, yes, we were talking about all those features, and I know that we mentioned TDE, uh, like, for example, transparent data encryption. So all those enhanced security features that help you be compliance ready. And there's some other technologies, like, for example, query performance enhancements, are part of the EDB Postgres AI distribution. So this is not part of Kubernetes. This is not part of anything else. It's just part of our database distribution. So this means that you simply use our container, our EDB Postgres AI container, in this case, EDB Postgres distributed. That's the version that you want to use. And you can deploy it using the PGD4K operator to take advantage of all those features and about enhanced security, performance, and all that. If you want to learn more, go to enterprisedb.com, and you will see, you can find the Kubernetes workload with links relevant to how we have enhanced the security features inside of Postgres, so you can use them in your Kubernetes deployment. Okay. So an additional question: can I ask you to, in a nutshell, what are the differences between the different operators you mentioned? Okay, sorry, I guess that it can be confusing. Just keep in mind that EDB, we contributed the CNPG operator, the cloud native Postgres operator, as part of the open source community. So you have the CNPG and PG4K, which is our original operator. They're exactly the same, except that PG4K has an additional patch to be able to control the advanced security features inside EDB Postgres AI. So with CNPG, you can work with the open source version of Postgres, but you will not be able to deploy the advanced features contained in EDB Postgres AI. If you want those features, you want to use PG4K. Now, here comes the curveball. The major difference comes with the additional operator that we have, the PGD4K. PGD4K has all the enhancements, all the patches, and actually it's a different kind of operator that allows you to deploy high availability, up to 5 nines of high availability for your database, but also allows you to build geo-distributed databases, as we were saying a few minutes ago, right? So we have 3 operators: CNPG for the open source version of Postgres, PG4K for the EDB Postgres AI version with the enhanced security features. And if you want high availability, geo distribution, you can use PGD4K. Okay, so hopefully that helps explain a little bit more the differences and similarities of the operators. Okay. I don't know if we have any other question. Looks like we're done. Any additional question? No? Okay. So then, thank you very much for joining the webinar today. I had a lot of fun talking about Postgres and Kubernetes. Please go to enterprisedb.com to learn the latest about Kubernetes. Don't forget to visit enterprisedb.com/training to get free training on this. Actually, we should be talking more about this. I need to make a mental note and promote this a little bit more often. So thank you very much for joining, and I hope to see you soon in another webinar. Bye.